Jai Hind everyone. Myself Achintya Pandey, as assistant professor in Information Technology Department at Ajay Kumar Garg Engineering College. Today I am going to discuss about uh, structural modeling using UML diagrams. Okay, so before developing the software, okay, before going to develop the software, we model actually we model the software. All the process involved of making the software, we model how we could visualize. Okay, so there is a structural modeling, and structural modeling need to be done. Okay, and this modeling we do by open source software, and that is called we have star UML and kind of open source where we could do the model by using UML, Unified Modeling Language Diagram. So UML is basically a tool, or you can unified modeling language, where we have the tools. By using the tools, we could represent all the process or activity or all the components which are required to model structural, okay, that we do. So there are basically these UML diagram consist of 9 diagrams, okay, where we could reach out all those things, okay. So the objective is to explore the structural modeling using UML diagrams, okay. So how we are going to model? So basically, unified modeling language, it is a graphical language for visualize and document model of software system, including their structure as well as design in a way that meets all the following requirements, that is visualizing, specifying, constructing and documenting. How we going to visualize, how we going to specify, how we going to construct, and even how we going to document, okay. So visualizing means a graphical representation with precise semantic, okay. So how we could use the tools to write the semantics and write or generate the graphical way, okay. Specifying means model are precise, it is unambiguous and complete to capture all important analysis, design and implementation decisions, okay. Constructing models can be directly connected to programming languages, allowing forward and reverse engineering, okay. Documenting means diagram captures all pieces of information collected by development team, allowing sharing and communicating the embedded knowledge. So it is basically UML is a way, right? So things could be before developing, before completing, how we going to visualize, so that we could do precise analysis and we could take decisions whether should go on or not, okay. So here to just for the structural modeling, mainly we do, or we must know the UML diagrams, where these diagrams are going to use for what representation. So a diagram is basically, it is the graphical presentation of a set of elements, most often rendered as a connected graph of vertices and arc, that is a relationship. So vertices or points are basically the things. So you draw a diagram to visualize a system from different perspective. So a diagram is a projection into a system. In practice, a small number of common combinations arises, okay. So these diagram basically all 9 diagrams are mainly required to do all kind of visualize, specifying, modeling and even documenting. So these popular diagram which we require, which we basically use to to represent, okay, to draw all those things which are required to make a prototype or just making a model. And these diagram are called class diagram, object diagram, use case diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, component diagram, and deployment diagram. Even not these 9 diagrams are sufficient. We could use more, we can generate, we could make even more of it, but somehow what we require can be fulfilled out of these 9 diagrams. Okay. So, in my earlier video, we have already discussed the object oriented concept, where we have used the object, class, object, and all over there. So, we know the class is a collection of similar type of object, like we have a student class, like we have employee class, like company and all, right? And object is the instance of a class, right? So, how we are going to represent the class diagram? I mean, how to represent the class? So, for that we simply require a rectangle. Okay, we could see this is the name of the class, this is the variable, and this is the functions. So, we know that a class could have, like if we make a class, for example, student, okay, class student. So, this is basically what it is, just like a structure. So, any class would have data type and there could have functions like A, B, and there could be data type. So, class diagram is nothing but the class diagram is represented just as a rectangle, and we could make this rectangle into 3 sections. First section we could write the name, second section we could write all those variables, and in third section we could write the functions, I mean member function of that particular class. So, this is class diagram. Here customer class diagram, this is the order, and even a special order is a class diagram, normal order, these all are the class diagram. Okay. So, these diagram basically we have shown for a order system of application, where a customer order. Okay. So, we have simply used this rectangle, and the association between 2 class, that is what kind of relationship are there, that we could represent as like 1 to 1, 1 to many, many to 1, many to many, and all those. Okay. Even we have seen here ISA relations is a relationship. This particular order, this order could have a special order, this order could have normal order. So, we would have the generalization, specialization concept, which you used as a feature of object oriented programming. So, that could be represented as a ISA notation, triangular component is there. Okay. Again, in all, I mean class diagram, we have 3 things which is common, that is the name of the class, that is the variable used in that class, and the function or method used in that class. Okay. So, these all are 3 things which we use in the class diagram. Object diagram is just, we know the object is what? It is the instance of a class. So, again object diagram is just like as a class diagram, where we simply, this is like C is a particular object of customer. So, we would have, I mean object colon which class this object belong, like C belong to customer class, like O1, O2, O3, these all belong to which class? So, order class. Similarly, S1, S2 and N1, these all belong to class special order and normal order. Okay. So, object diagram is also represented by a rectangle, where we the first is the instance, that is the name of the object colon name of the class. Okay. Then we have component diagrams. So, component diagrams are basically used during the implementation phase of an application. Okay. What components, I mean implementation, how we are going to code, what type of files are required. Okay. So, before drawing a component, we require following artifacts are to be identified clearly. What kind of file used in the system, Java file, any I mean DLL file, or what kind of library, what other library we are going to use. Okay. So, library, other artifact relevant to the application, and what are the relationship among the artifact. So, here we have taken an example of order management system. So, for that we are going to represent all the class, order, and several diagrams for this particular example. So in particular, here we have four component, like we have made customer file, customer page. So we have made in Java, so we require as a customer.java. One is then order, then special order and normal order. Okay, so customer order, right? This order could be normal or special. So we have seen the association or relation. Order cannot be this arrow cannot be in the reverse direction. From order to customer it could not be. From customer to order it is okay. Okay, so this is called the customer diagram. Component diagram. Deployment. Next is deployment diagram. Deployment means how we going to implement over the internet. So what are the nodes, or you can say various nodes we require just to put the internet. So even for the order management system, we require user, we require some system where we could place the order. Then we may require modem, internet. Okay, these all are some kind of server which we are require. Okay, like caching server, server 1, server 2 for that particular application to run. Okay, so this comes under the deployment diagram. From user to over the internet, what different nodes are required comes under the deployment diagram. Okay, so component diagram and deployment diagram are closely related. Deployment diagram are useful for system engineers. Okay, and efficient deployment is very important as it controls the performance, scalability, maintainability and portability. And so we have reached just the class diagram, object diagram, component diagram and deployment diagram. So the next is use case diagram. So how many cases? So use case diagram is basically these all are considered for high level requirement analysis of a system. When the requirement of a system analysis, the functionality are captured in use cases. So all those functionality are captured under the use cases. So we have in use cases we would have actor and various activity, or you can say various methods. Okay, so your customer is an actor and the use cases could be the order, special order and normal order. Okay, so customer order, so how these all are the some functionality and this could be represented as a use case diagram. Okay, okay, so next one is the interaction diagram. So in interaction diagram, there could be sequence diagram as well as collaboration diagram. So sequence and collaboration diagram are moreover the same thing. In sequence or collaboration diagram, that is combined together are called interaction diagram. So in which we mention the stepwise type activity, how we going to, what are the first, what are the next and so on, what are the last. So in interaction diagram, we had customer order, special order or normal order. So we see that there is a first, there would be initialization phase, then customer send order. If order gets confirmed, then it is confirmed and returned after dispatch. So this is this comes under the sequence diagram. This is the representation way we would have to identify all those functionality into a rectangle, and this shows the sequence. Okay, collaboration. In collaboration diagram, we required to put it into order. What is the first, what is then second, what is third and what is the last. So even for the customer order management system, the first one step is initialization. Then we would have customer, how customer, because send order, customer will order, this comes under the first thing. If order gets confirmed, so this could be the second phase, and finally when it is confirmed, then the dispatch will be there. So we put 1, 2, 3 and 4, 1, 2, 3 and so on. Okay, so in collaboration diagram, the method called sequence is indicated by some numbering, like 1, 2, 3 or ABCD, something like that. The number indicate how the methods are called one after another. Then we have state chart diagram. This state chart diagram consists various state. Okay, like idle, like send order request, like select normal or special, like order confirmation, dispatch order. Okay, so we could represent in this form of This comes under the state chart diagram. This is very important for describing various states. States can be identified as the condition of object when a particular event occur. Okay. So before drawing a state diagram, we should clarify the following point. We would have to identify the important object to be analyzed, identify the states, identify the events. Okay. Then we would have activity diagram. Activity diagram is just similar like as a state chart diagram, where we could write various activity like customer send an order. This could be one activity. Order request system confirm the receipt of the order. So all the activity, right, semantically activity could be put under some thing. Okay. So this is the activity diagram of a order management system, where we see the various activity performed. Okay. So even just to draw the activity diagram, we require the following. What are the activity? What are the associations? Means what is the relationship between two activity? Structure modeling using UML. So we have identified the common diagram which we require to model any software or any application before going to exact implementations or exact developing. Okay. So these diagram include class diagram, object diagram, use case diagram, sequence diagram, collaboration, state chart diagram, activity diagram, component and deployment diagram. Out of these diagram, we could model any application or any software processes. Okay. Even more than that, we could write other things.